In this tutorial, we are going to simulate the flow around the front wing of a Formula car. And now we need to import the Formula car front wing geometry. We used to generate the geometry from here, geometry 3D CAD models, for example, in backward facing step flow and also the flow around aerofoils. But this time, since we already have the geometry and they are surface geometry, we can import the geometry using another method. So by clicking import surface mesh, and this is William F1 front wing, and we are going to open it. We can accept the default parameters, click OK. So it's been imported now, and you can see it's very nice, streamlined Formula front wing. Okay, and actually, you might already have some idea or some understanding about this. The functions of this front wing is used to generate downward force, which helps car to produce more grip on the road. And it's basically the upside down aerofoil. Okay, so we have the geometry. The simulation would be like put the front wing in a wind tunnel. And because you can see now the front wing is symmetric towards its central plane. So in the simulation, we're going just simulate part of half of it. And okay, so the next step is to generate a block as a wind tunnel. So what we can do is in parts. So click parts, and we can see this geometry, front wing, and we go back to parts, right click, and new part shape. We are generating a block wrapping around this geometry. Okay, so block. Now you can see the block is snapped to this geometry. But we want it to be larger, right? So we change two corners to define the size of this block. Okay, so for corner 1, we can define its x is minus 4 meter and y is minus 0.03 and z is minus 0.9. Okay, and you can see basically what we've changed is this point. And if we have a side view, let me change to the side view. Okay, and let me move it a little bit. Okay, it's better to have it the other way. Views. Okay, so basically we change this point. It's minus 4 meter downstream from the origin, and the origin is in here. So minus 4, and y is minus 0.3. So here, this distance is minus 0.3 because there will be a wheel. So this is a flow we are going to simulate, and z is this coordinate. So it cuts through the center plane of this front wing. Now let's do corner 2, and which is 1.2 meter, 1.5 meter. Oh, sorry, 1.5 and 1.5 meter. Okay, so now you can see the dimension of this simulation. Yeah, this is a virtual wind tunnel space. Then we create. Remember, just click create once, otherwise you will generate several blocks. Okay, just click once, and now you can see the block in here, and we can see the surfaces. And the next step is we have the block. Later on, we will set this as inlet, different boundary conditions. So we need to separate the surface into different regions, different patches. So we click here, block service, right click and choose split by patch. Okay, you will get a sequence of services and you might have different numbers, but now the task is to rename each service and split them. So let's first do inlet. So once you click a service, it will be highlighted into purple or pink. So we set as inlet and click once. Okay, so once it's splitted, it will disappear. And we click the outlet. We will change this into outlet and create. And we know this is a floor. Okay, floor, create. We know this symmetry plane. Symmetry plane. Okay, create. So the last two won't be, if we, these two will become exterior. And if we click both, choose both, we won't be able to create. So we will just rename it later. Okay, so this basically is exterior service. We can simply rename it into exterior wall and enter it. So now we have all the boundaries: inlet, outlet, symmetry plane, floor, and exterior. Okay, so we have the wind tunnel, virtual wind tunnel now, and we have the formula car. And you can see this wind tunnel, virtual wind tunnel, just wraps half of the front wing. Okay, and so similar as the aerofoil simulation, we want to exclude the geometry from the wing, from the block. Then we can build up the simulation domain. And what we do is click both, like this. Okay, we click both, right click, and choose Boolean and subtract. And we keep it as it is. The target part is block. Okay, then you will see a subtract. The subtract is a domain, the entire domain, and excluding this the formula car geometry, and you can see here. So this is the surface generated by the subtract, and exterior, floor, inlet, outlet, and symmetry plane. So this is what we have. Okay. So now this will be the simulation domain. And okay, so this is still parts. Then we can right click and assign part to regions. So this step allows us to set up the boundary condition. Okay, so you can see we need to highlight the subtract part, and it's very important to change the middle option and create a boundary for each service and apply. Just apply once, remember, and close. Okay, so in the regions, we will be able to see um, the different boundaries we have. Okay, so this now later on, once the physics is set, we can set up the boundary condition.